Okay, welcome everybody, and thank you for joining us for our next presentation. My name is Matti Saarinen, and I'm the Sales Marketing Manager at the Proc Solutions Finland. And we are based here in the cloudy Helsinki. And thank you, Bingen, for setting up this nice event. Feels like the European Song Contest, except the songs are now much more technical. So next, we will hear a presentation of a topic called Workflow for Live UHD HDR Premier League Football. And it will be presented by Mr. Prinyar Boon. He's a product manager at the UK-based Phabrix Limited, and he has over 35 years of experience of high-end broadcast production technology. And of course, Phabrix is the world leader in broadcast test and measurement solutions. And if you have questions, please type them on the right-hand side of the portal. Okay, now we will switch over to Prinyar. So please, the platform is yours.
Thank you, Matti, and hello, everybody. So thanks for the opportunity for talking. I'd just like to share some of the experiences we've gained over, well, quite a few years, actually, in getting live HDR up and running and live in the UK. So this is based on a masterclass I gave with Andy Beale, Chief Engineer of BT Sport at IBC in 2019. So I've been asked to condense a 1-hour presentation into 30 minutes, so this will be a bit of a rapid run through, and so please bear with me. So this all led up to the launch of the BT Sport Ultimate channel, and what BT Sport's vision was that they wanted to be the heart of sport. They went live with this with an HDR event-based service in August 29 at the FA Cup Community Shields, and it builds on their Ultra brand, which is already available in UHD 4K and also with Dolby Atmos, the ultimate viewing experience. So they feel that HDR with Atmos and UHD is the best you can get in the home today, and can give a very compelling experience. And also even in these times of COVID lockdown, and with remote production and synthetic sound as well. So that's all going on today. Obviously, launching this is an extremely complex topic, and how do you add HDR onto an existing SDR service? It's a bit akin to doing open heart surgery on a marathon runner, to be honest, because you really need to have negligible impact on the existing service, OPEX and logistics. You can't necessarily add extra trucks and the like. Those were done with experiments over the years. So a lot of work was done into condensing down this work into something that could be used day in, day out, operationally and commercially viable. And we also work very closely with some of the camera manufacturers. I know Paul DeBress is online here from Grass Valley, so reach out to Paul and those guys. We started work in 2014 with Paul and the crew, and also with Sony as well. So we've been working to ensure that whatever architectures can work with a range of cameras and devices, and is agnostic to that. The other thing about a conventional schedule is that I think BT Sport last year they did 5 HDR matches back to back on a Friday, Saturday, Sunday, Monday, Tuesday. So the overall schedule cannot be extended. You've got to be able to go in there with your conventional rigging, do your fax check, and then go live and in the space of the normal 2 days operations. So we've had to have minimal impact on the way that these events are set up. We've introduced what's called an HDR fax check into the process to check some of the workflow there. But this is tight running, and you have to. It's live production and has to keep on going. You can't stop, and there are a lot of deliverables associated with English Premier League football. So English Premier League take an ISO feed of every single camera, for instance, in SDR for their own service. There's world feeds that go out in a variety of SDR, UHD and HD formats. BT have their own internal deliverables for the BT Sports service. There's on-screens, stadium jumbotrons and the like. VAR, as you know, is has its own requirements as well. And then there's also studio links and in-vision monitors. So all of these have to be must not be affected. There are contractual obligations, and you have to blend in the HDR workflow into all these deliverables as well. So that's it's not just about the program. Also, while people talk about transmission and typically HLG and PQ in the formats, I kind of assume people are familiar with this. On the production side, you have a lot more variables in there. You have HLG and PQ. You have also Sony's S-Log3, which is now supported by both Sony and Grass Valley cameras. Sony also have a variation that called SR Live, and Sony have a variation called HLG Live in the production space. Also point out that Grass Valley is the only camera manufacturer to support HLG PQ and S-Log3. They're unique in that. And so whenever you're kind of designing an architecture, you want to ensure that you're going to be compatible with a wider range of camera and equipment providers as possible. And BT Sport were also, for their particular service, we're looking to go to apps and mobiles. So for transmission, they decided on a PQ deliverable, which is also used by the Blu-ray format. And eventually, for a number of reasons, they ended up using S-Log3 as the HDR production format, and so that is converted to PQ for contribution and transmission. But there was quite a complex commercial technical evaluation of all the options, and an HLG and native PQ were all looked at as well on this. But you have to bear in mind that because there are so many different production choices there, that many of the deliverables we talked about previously, some people may want an HLG output, some may want a PQ, some may want an S-Log3 output. And similarly, if you've got a contribution feed coming in, that could be in any one of the 4 or 5 HDR formats coming into the native system as well. So you now have a whole raft of HDR to HDR conversions, as well as HDR to SDR conversions, which we'll talk about. Now, this went live, we talked about in August 2019, and really this was on the back of a whole range of experiments that started originally with Grass Valley in MotoGP in Valencia 2014, but by 2019 we just got to the point whereby the full range of equipment in order to make a complete TV program, along with RF cameras and also replays and super slow-mos and everything else, was now available. Whereas previously, I mean, we did the 2017 UEFA Champions League final, which is a 4-hour production there, and as a bolt-on, but the match cameras themselves were in HDR, but the rest of the 4-hour program wasn't. There was no RFs, no replays, no studio. That was all in the conventional SDR. And looking at it, out of the kind of 4-hour program, only about maybe 70 minutes was in HDR at the time. Now in 2019 and 2020, the full package is now in is potentially in HDR with full HDR studio, RF feeds, Steadicams, and replays as well. So it gives a, we moved on to and graphics. So we moved on to a complete HDR production for the entire show. So that's quite a big step forwards, and there are knock-on effects from some of these approaches. So architecturally, back in the day, the idea was not to sort of disturb the original SDR production. And so what people had was this kind of a concept of an add-on or a bolt-on or parallel system, whereby you'd be running either sometimes even 2 vision mixers, one running SDR, one running HDR, or even different buses, and you would keep the two sides completely separate, and the camera, be it a GV or a Sony, could give you 2 simultaneous feeds from the camera. So all the early experiments were done this way, as a kind of a parallel exercise, even to the extent whereby sometimes there are 2 sets of cameras. Now, that means that the SDR production itself is sacrosanct. It's not changed, but it is expensive, and it is quite cumbersome to tie these 2 systems together in order to to give you this parallel feeds, but it has been done, and notably HBS did it for the FIFA World Cup in Russia. That was how this was done, albeit on a bus basis. But we also had done experiments with slaved kahunas, in fact, between the primary and secondary devices as well. So this is how we used to do things. It's not really commercially viable on a day-to-day basis. This is what we are looking to move to, if you like, is the Holy Grail, where we have a single HDR production, if you like, and we can convert that to other HDR formats for contribution and for transmission, and we then derive the SDR service from the HDR service, and this means that the whole thing is completely integrated. You can condense down the amount of equipment, but in order to do that itself is quite involved. And some of the key techniques that we kind of developed, well, I'll share with you. These aren't complicated. We've made every mistake in the book getting here, so it was nice that the final answer was quite straightforward. In terms of compliance and monitoring, HDR as a production is quite straightforward. You are taking full advantage of the latitude available in modern cameras, which can be with a high def 2/3 inch camera, like the LDX86N or the 100 is over 15 stops, whereas conventional television is kind of limited to the perhaps 10 stop range. So HDR, it's quite simple to shoot HDR. It's very complicated though to shoot simultaneous HDR and SDR and make sure that both are working at the same time. And in order to derive good SDR from HDR, then you have to be aware of the limitations of your converters and tailor the entire production to the technology you've got to achieve the look that you wish. And converting between these HDR and wide color spaces down to SDR is not an exact science. So and the technology and the standards have moved over the course of the years that we've been doing these experiments and launching the service. The other thing this is a very strange concept that I'm going to introduce to people, is that HDR is actually closer to audio than conventional video. So if you've ever worked in the audio world, you're aware of line-up levels at -18 and -20 dB. And in HDR, you have a concept of 100% or 200% exposure. So like the 700 millivolts of white that you have today, that's no longer the reference. And that's a huge change in conceptual thinking. You also have a essential thing called max fall, which is available in Blu-rays, and that's equivalent to long-term loudness. The true peak is a thing called max CLL. You have artistic compression in audio, and that's very similar to the way the camera knee and toe is applied at the camera. And you've also got to map SDR to HDR, which is how do you take all old audio equipment sound and bring it to your modern 5.1 immersive sound, and vice versa. How do you generate stereo from 5.1? How do you take 7 and 9 from HDR 2020, and how do you produce the two simultaneously? So all the challenges that are there in the audio world are now introduced, if you like, with the introduction of HDR into an SDR environment, and technically. Many of these are actually conceptually are very, very similar. So if you're new to this, go and talk to your audio colleagues, and they'll laugh and say we've been doing this for years, but understand what they do, and that will perhaps give you an insight into the difference between conventional SDR video and HDR video. Now, the other thing about HDR is that you'll see it a lot in the movies. Now, bear in mind that those productions are highly controlled. They can control the lighting conditions. They're all post-production graded. In live production, if you've set up all your converters down the entire chain and you've made a mistake, once you've gone live, it's too late. You're live. It is very, very difficult to change them once you're up and running. You have no control over the lighting conditions. We did a famous FA Cup I think it's quarterfinal, where it started out in bright sunshine. It had with a shade line on the pitch. It then went cloudy. It started to rain. It started to hail. It snowed, and this is classic UK weather conditions. And it came all the way back to bright sunshine in the space of 90 minutes. We had no control at all over what was going on, but you have to adapt the system, and the choices you've made in the operating parameters have to be able to accommodate that the real world dynamic range of live action. It's with pitch-based sports, everything tends to be pointing at the pitch, but you can imagine motorsports where the cameras can be pointing north, south, east, west simultaneously, and you'll be cutting from camera to camera, and they are pointing in different directions. So in the real world environments and genres, you have to bear that in mind and design your system accordingly. Also, you have to balance live action with the graphics, because both of these have to be matched in their settings and converted from HDR to SDR. And you need to ensure that you have high quality SDR live action and graphics to meet your SDR deliverables. So this is quite complicated to set up and calibrate. But once that's done, the idea is it's hands off, and then the rest of the system can get up and running. So with Phabrix, we have reference test patterns and signals, which I use to calibrate and measure the equipment in the system, make sure that everything was balanced and match the overall operating parameters that we'd chosen after sort of years of experimentation in the field. So you need a simple adaptation to existing truck. It must be compatible with remote and distributed production. So this is now is working in the UK with Project Restart, with all the productions done remotely. So HDR is still going there. There's a new supervisor HDR role, which has kind of end-to-end responsibility, not just the truck. You need at least 10-bit data paths everywhere. So your replay servers need to migrate from 8-bit codecs to 10-bit codecs, and as do the RF cameras. That has an effect on the number of replay channels that you can get, and you need to increase the number of replay servers you have. And then the key thing that we introduced was a very simple concept in the end, which we call closed loop shading, and I'll talk about that later. And this works for all camera manufacturers and camera types or production formats, and it actively guarantees the SDR production while giving us simultaneously HDR to SDR output. And we tested these systems, the architectures, with as many locations as we could to ensure this was going to work. I said starting back in 2014. And you also have to train your production staff to do this as well, and calibrate your equipment. So it's quite common for people to mistakenly send SDR down the HDR path and vice versa, and get the graphics levels wrong. So people need to be aware of that, and be able to quickly spot that something's not right, and pick up the phone to the people. A long runway of events. I think in 2019 I did over 25 matches. What you can see here is in fact a shot from the Champions League final from Liverpool and Tottenham, and in fact that's my phone at the bottom on the right hand screen, which was it's an HDR phone, or capable phone, and that we were taking the reverse feed from the UK and bringing that back to the truck, so we could see what was going on. It's an HDR monitor on the left and an SDR monitor on the bottom right there. So we've done a lot of events and proven out these systems. Quickly run through. This is typical life on the road. This is what you get. I'm sure you've seen this. You're familiar with this, and it's crowded on here. So the point I'm making is it's not a COVID point. This is that there's not a lot of room to put extra equipment in here, not a lot of space to extra people. And this is the kind of typical camera racks area. These happen to be Sony cameras in this particular truck. And so we have to adapt the truck for HDR, but these trucks have to do SDR production as well as HDR. You can't just say they do one or the other. And so there's a number of pieces that need to be changed, but you need to make sure that the truck retains its flexibility. So this is the vision supervisor's position. This is before on the left, and now fully integrated on the right here. These trucks originally were designed for 3D operation, so there was if you like, a spare stack available, and you can see there's an HDR monitor below, an SDR monitor above, and then a multi-viewer, and that allows the HDR vision supervisor to have all the technical monitoring that they need, and also to look around the rest of the chain and have the reference HDR image as well. And they're physically sat next to the racks operators who are racking in SDR using closed loop shading. This is, I think, Telegenics T19, showing the overall suite. So the station on the left is the guarantee. The next station, the HDR vision supervisor, and then you can see the racks engineers. So that's kind of a typical layout that was adopted for these trucks. And we talked about there. This is we talked just an expansion of the previous picture. So closed loop shading, it's a very simple concept really, in that the shaders carry on shading in SDR. They unfortunately never get to see HDR. They have actually requested to have an HDR monitor so that they can have a look at what's nice pictures that are going out, but their job is to make sure that the SDR pictures are actively monitored. And the idea is that you take the HDR feed and then you down convert it through a reference HDR to SDR converter. And that's what the camera operators touch down to. It's a very simple concept, but it means that they're actively monitoring the HDR to SDR conversion and controlling the exposure and black level and colorimetry, if you like, of all the cameras, of the main transmission, and also of each camera individually, so to make the two match. So they carry on working in normal, in a conventional way, that there's no change to what they have to do. And that was a very important conceptual piece to fit together. So fundamentally, what you see is what you get. It matches the current working contractual practice. The vision supervisors can do their job and control the look of the production. The reason why you shade in SDR is that SDR exposure is critical. A quarter of a stop is kind of the typical latitude that you have. We talked about before, HDR exposure is much forgiving, and also mentioned how wildly the weather can vary in the space of 2 hours. So the racks operators, the shaders, are constantly having to track the weather and lighting conditions. And it means that if there are any errors, you have many people in parallel looking at this, and you can spot this thing that's going wrong very quickly. So you can end up, depending on the camera system, you can end up adjusting the HDR camera controls but monitoring in SDR on the output. So that takes a little bit of getting used to. There's a training exercise that the shaders have to go to adapt the new method of working on the controls there. But there's fundamentally no change to their monitoring equipment, although they have to learn a new set of HDR controls. And the down mapper in the system is key, because that's what's required to deliver the SDR look. And there are different philosophies as to how you do this. Sony have one philosophy, and GV have a much more free form and, if you like, a larger control range that allows the shader greater latitude. Sony tend to have a more canned presets set of controls with some variations. So the idea there is that having made your choice of camera, you can carry on working with the controls that you've got, and this is a simple change to the system and the architecture. This works for both line and RF cameras. And also any SDR cameras that are in the system then map to HDR and also pass through the down mapper, and essentially everything common modes through that. And this can be applied to any HDR format. So that's again, it gives you complete independence as to one day your truck may be in HLG, next time you have to switch to SR Live or something. So again, you don't have to rewire the truck, and the architecture remains the same. One thing I would recommend is don't use backwards compatible HLG for shading. There's been a number of experiments for that. sometimes it works, but under classics kind of soccer lighting conditions, it's very hard to get a match between the backwards compatible HLG image and the true SDR output of the truck. I won't go into that now. I've got time to cover that in more detail. Now, one thing Grass have introduced, and this is kind of an evolution of the work that was started in 2014, is this very, very advanced camera control panel with the, I think there are 4 levels of controls there that you can have on the joystick, and this creative grading concept that they've pieced together. So that's taken, this is taken what I've described, if you like, to the next level. And so I, go and talk to Grass and have a look at what Paul DeBresser and his colleagues have pieced together there. It's very innovative, and it allows you a lot of flexibility in creating your HDR and SDR productions. So conversions, now we're introducing a new concept into these systems. We've got to convert between HDR formats, and we've got to convert between SDR and HDR, and vice versa, because you still may have a mix of SDR cameras in your HDR system. You may have SDR replays and or VTs coming in, and you've got to convert between a 709 HDR and a HDR 2020 color volume. It's known as Gamut mapping, and you can also convert it by one of two methods, via scene light or display light, depending on which you think is appropriate. So, but just again, conceptually, to introduce you to the fact that there are 2 ways of doing this. And the choice of whether you choose scene or display referred kind of depends on what type of content that you're trying to process. And this is some of the recommendations from the ITU, which talk about adverts and test patterns and graphics, but also live cameras. But then you'd end up with situations here. So this is kind of the mapping problem. You've got an HDR 2020 wide color gamut, very large volume, and you've got conventional SDR 709 in the middle. Now, the good news is that converting from SDR to HDR is theoretically possible, because obviously the HDR volume is bigger than the SDR. Going from the other way, though, from HDR to SDR, we clearly have to lose something. We've got to throw something away, and that is normally done by color graders in the movie world, but we have to do this live using low latency real-time equipment in TV production. So that's quite a challenge to do that, and there are many different versions of equipment in the market now that with this capability. But all of that we talked about, and is how do you apply it to this kind of scene? This is a photograph of a Sony monitor. You can see the top left of the studio feed, where you've got cameras here which were running in a different setting to the outdoor cameras, and they also got a mix of the studio and the graphics. So it's actually very difficult to ensure that all the colors that are in that studio feed and also in the graphics can be mapped seamlessly through this process, and it's a compromise to pull those together. In fact, I can tell you the sort of cyan vertical bars there that are in that picture, when they're shot in HDR 2020, they're actually deep blue, and they turn to cyan when you put them through the HDR to SDR converter. So that's another variation. You'll also find that I think like Liverpool shirts and Tottenham Hotspur's training strip is also outside 709. So even some of these team colors that you're used to, and even the grass, part of the grass is outside of 709. So trying to maintain all those colors and match them is quite complicated. And here's an example. This is not staged. This is from the Women's Super League final in Brighton. Pitchside interview with Claire Balding, who she turned up in a bright red coat. She's has blonde hair. You've got the grass there, and you've got the Brighton Seagulls blue, and you can see on the CAE chart the fact that Claire's coat is outside 709. The Brighton Seagulls blue seats are outside 709, and part of the pitch is also outside 709. So here's an RGB test pattern, if you like, using a real world example, but this is what you have to do when you're processing these HDR 2020 images. Now, we talked about those quite simple bolt-ons at the very, very beginning. We talked about closed loop shading, and we also talked about all of the different inputs and outputs and deliverables you have. And we also talked about the conversions you need and whether they should be seen or display referred. Putting all that together, this is what you end up with. And this is kind of a high level overview of the different ins and outs to the truck, the different conversions involved, where the replay servers are, and whether the converter is seen or display referred for the different processes that go on within the truck. So each of these here, we had to figure out the best conversion to do, the overall gain settings and black level settings for the HDR service, the difference between the two, to ensure they're all calibrated. This was not so bad in the truck because this was all typically the same manufacturer. It got more complicated when we went down the main transmission feed because the equipment in the truck is bought by the truck provider. Redby for transmission have a different standard, and they have all their alarm systems and everything else is integrated in with that. What Stratford have is different again. So one of the jobs that we had to do was to ensure that all of these down mappers gave a very similar output. Technically, are they the same? No, but we have a concept called a just notable shader difference. So that's the idea is if you put two camera shaders together and say, what do you think, guys? They'll go, that's acceptable. And so that was kind of the reference that we adopted in order to deliver this. It's a new unit of measure, but I'm afraid we haven't developed the AI to condense that into something that we can use operationally or computationally yet. The other thing as well is that it's very important to bring the SDR reverse feed back from Redby, and this is particularly the case in this year when we had UEFA Champions League, Europa League, and the Champions Cup from Istanbul, which are all HDR productions, but they were in a different format and with different gain settings. And also we had an HDR studio locally, and we had to blend all those together, make sure the whole lot would then go through this final converter, and we had to make sure the whole lot was a seamless blended HDR and SDR system going through this entire chain. So we were monitoring this reverse feed and bringing that through. You have all this as well. You saw before all those different systems in there. They've all got concatenated compression, so you need to bear that in mind. And there's many, if you look at the signal path or flow for any particular item, you can have a lot of conversions in there. So ideally, you'd minimize the number of conversions and the number of concatenated compressions, because HDR in 10-bit is fragile, and you essentially lose some effective number of bits with each conversion, plus losses associated with compression. So if you want to maintain the highest technical quality, you need to consider all this and bear that in mind. And as you see, it does get very involved. And also different suppliers will have different views on what they think is appropriate for their international feeds. So that's you have all this complexity now, and this is something that the OBS were wrestling with for the Olympics, which will obviously being deferred to next year, and also would have affected the Euros had they happened this year as well. Also, one thing to bear in mind is a thing called an HDR gain offset. This is, again, a new concept. This is used by all production formats. You don't have to do it, but it is quite common to do that. But it means that when you mapped it down to SDR, you have to remove this. And not everybody uses the same number because what they regard as HDR is there's a different interpretation. So if Sergey is sending us at neg 10 and we're in neg 3, we have to accommodate the 7 dB difference, and you need to know that as it's coming in, and agree those numbers prior to setup. It's not something you want to be trying to figure out while you're on air, and that has happened actually once. The supplier didn't pick up the phone, and we didn't quite know what gain offset they were using. We had to kind of guess, and we finally dialed it in at half time. But that's, I will not name the event or how that happened, but it's so as people are learning about this is sort of things you have to bear in mind. Also, the gain offset needs to be applied in HDR space, and a lot of equipment is adapted from SDR usage, and so the converter may be on the input side or the output side. It's not necessarily on the HDR side, because obviously when you're converting from SDR to HDR, the HDR is in the output. When you're converting from HDR to SDR, the HDR is in the input. So you need to have a Proc amp that flips depending on which direction you're going, but not everybody has that. And so one of the things I had to do was just go through and evaluate those, and also trying to normalize all their control ranges so that everything did the same job as it went down the overall system, and work with the manufacturers to piece that together. So, so that's it basically. I've had me half hour, just over now, and this was available as an IBC 2019 production masterclass, and that's the link there if you want to go and look at it for yourself. Thank you.